Today's lesson is going to be on how to graph lines, and we're going to be using something called a t-table to do so. You may know them as t-charts. So a linear equation is an equation for which the graph is a line. So all equations make some kind of shape on the xy plane. Linear equations make lines, and it's pretty much in the name. You see the word line in the word linear. So the equation of a line generally looks like y equals mx plus b. This is the equation we used previously when we were translating tables into equations. These were all lines. You may also see an equation of a line in this fashion: ax plus by equals c, where the a, the b, and the c are whole numbers, integers. But remember, all lines are also going to be functions, so you can just change the y value to f of x. It means the same thing. It's just written in function notation for f of x equals mx plus b. So remember, all lines are functions. This is on your notes, so make sure you fill in the blank for the next piece. There is only one line that is not a function. Think about it. Which line is not a function and fails the vertical line test? So remember, all lines are functions. I'm just going to do a quick graph right here. Here's a line. All lines pass the vertical line test. There's no way I can draw a vertical line that's going to hit this line more than one time at every spot. So all lines are functions except one type of line, and that line is a vertical line. If I have a vertical line and I draw a vertical line to check using the vertical line test, it's going to hit it at all points, so it fails the vertical line test. So remember, the only line that is not a function is the vertical line. So make sure you fill this into your notes, vertical lines. Feel free to pause it if you need more time. So again, linear equations, or linear functions, as we may call them now, is an equation whose graph forms a line. In linear equations, all variables are to the first power. So again, all variables do not have little exponents, so they're all automatically invisible ones. So they all have exponents to the first power. So here's an example: 3x minus 4y equals 11, where 3 is the a, negative 4 is the b, 11 is the c. All you will ever see when there's actual numbers on it is the letter x and the letter y. This is a linear equation, or a linear function. Here's another equation. This one is not linear. So let's think about what makes this equation not be linear. So let's going back to the definition. Everything has to be to the power, the first power. In this case, the second equation has a little 2 power, so it's a squared on it. That means it's not linear. It's actually something we call a quadratic equation, which we'll be learning about later on. So what is a linear equation? Once again, it's an equation in a linear equation is an equation whose graph is a line. So again, line, line, line. So here's a graph. Let's go ahead and see what it looks like. So here's an equation where the graph is a line. It's linear. I'm going to show you guys an example of the quadratic we saw on the previous slide, but it's equation. Now we're going to look at its graph. So quadratics, when you graph them, those are the ones that have the power of 2 on them. Actually look like this U shape, and we call these parabolas. But they are not linear. They're called parabolas. They're quadratics. So again, all linear equations have 2 variables, the x variable and the y variable. For example, here's another equation: 2x plus 3y equal to 12. So the solutions to this equation are ordered pairs. It's an x value and a y value. We need to have both because the equation has 2 variables. And we want to find points that make this equation true. So there's more than one point that you can substitute into x and y, which will make it equal to 12. One such example would be the numbers 3, 2. The reason why is if we plug in the number 3 for the x and the number 2 for the value of y, 2 times 3 is 6, 3 times 2 is 6. Let me actually use a marker for this one. So that's going to be 6 plus 6, and that is equal to 12. So it checks off. The ordered pair 3, 2 is a solution. It's a value that fits into the equation and makes it true. So that's what we call a solution. We'll get more into that next week. So just, those are x values, those are y values, we plugged them in. So if we were to find all the solutions besides the number or the ordered pair 3, 2, we would have a collection of a whole bunch of ordered pairs or a whole bunch of points. All these points together, we could take them and put them on a graph. There's 3, 2. Here are a few more solutions. The point 0, 4 is another solution. If you were to go ahead and plug it in, it would equal 12. Here's one more solution, the number 5, 0. If you were to go ahead and 1, 2, 3, 4, 5, 6, 0, I'm sorry. If you were to go ahead and plug that one in, that one would also give you 12. So these are 3 solutions. Here's one more. The number -3, 6 would also be a solution to this equation or to this linear equation. The solution -1, and that looks about 1, 2, 3, 4, 5, and maybe 3/4. That's also another solution. So there's a whole bunch of numbers that we could plug into this equation here. Wrong one. That would make it equal to 12. And if I kept going on and putting every single point on this graph, something approximately looking like this, and if I kept going and going and adding more points and more points and more points and more points that are all solutions to this equation, eventually all these blanks in between would start filling up, and I would eventually get a solid line from all of this. So again, all these points together would eventually make a solid line. So let's look at a nicer line. So you would just connect it. So there is no point in finding 10, 20, 30, 40, 50, 60 points because we know that they're going to line up since it's a linear equation. So a few points is enough to connect them, and that's all we need. So that's what we're going to be working on. So these are the steps to graph. So you guys are going to fill in the blanks. So first thing you want to do is make a t-table. So we want to make sure that we have some points to graph. We want a minimum of 3 points, and I'll talk about that in the first example. Second thing is we want to graph each ordered pair. So we want to make sure we graph each point on the XY plane. So we're going to take all our points and locate them on the graph. The next thing we want to do is we want to connect all these points, and we want to draw that line. Once we have enough points, we're just going to connect them, and we will be done making our graph. So just to recap, make the t-table, find some points, plot the points, and then connect the line. So here's our first example. So you have plenty of room to write there, so make sure you guys space out your information. We have this t-table. So generally we stick to numbers like -2, -1, 0, 1, and 2 on our t-table because they're small numbers and they're pretty easy to substitute and evaluate. You do not want to choose numbers like -10, -20, -100, 40, 50, because they're going to be off the chart. And you want numbers that are going to fit on your chart. Notice that it only goes from 6 to 6. You can always extend the graph, but as long as you can fit some points within our graph, we should be fine. If they fall outside the graph, we just won't plot them. So let's go ahead and start figuring out the y values that pair up with the x values that I have chosen for you. So let's start off with the first one. Let's start off with -2. So what goes with -2? So when x is equal to -2, I just take my equation and I'm just going to plug in the number 2, -2. So I'm going to go y equals -2. I'm going to substitute the number. I'm going to change the color. -2 in here. Make sure you write this out. I'm going to be looking for this on your notes and on your classwork later. So now that we've substituted the number -2, we're going to go y equals -2 times the -2 is a positive 4 plus 5, and that gives me 9. So I'm going to write in a 9 on my t-table. That's my first ordered pair. I can graph it now or graph them all later. It doesn't matter. So I'll just go ahead and do one at a time, and then I'll graph them all at the end. I'm going to go ahead and move on to my next point. I'm going to have -1 as my number I'm going to substitute. So -2 times -1. I'm going to substitute that in. for x, and I'm going to evaluate. So let's see what I get once it's all said and done. Negative times a negative is still a positive. That's going to give me 2 plus 5. So my y value is now 7. Let's go ahead and move on to the next one. We're going to plug in 0. 0 is always going to be your easiest number to substitute because multiplying by 0 eliminates everything you have. So let's go ahead and plug in our 0. That's going to give me y equals to 0 plus 5, or just 5. It's going to be my next number. And at this point, you might notice a pattern. It's because we've gone over this before. As you go down, it's changing by 2. So let me just go ahead and mark this off. So let's go ahead and go forward. So as we see our y values, you notice that the 9 goes down to a 7. And from 7 it goes down to 5. You can see that it's decreasing by 2. The reason why is because my change here is negative 2. That tells me that each time it's going to change by 2 and it's going to go down by 2. So let's just go ahead and do the last 2 using that pattern. But I do want to see the work for the first 3. So let's go ahead and fill that in. So if I take away 2 from 5, I'm going to get 3. If I take away 2 from 3, I'm going to get 1. So now I've got 5 ordered pairs. So what all of these mean is the first one means negative 2, comma 9. You don't have to write this part down. The second one means negative 1, comma 7. The next one means 0, 5, and so on. So this is just a way of writing points real quick instead of having to write them out separately like this. So we're just going to go ahead and graph the points that we have, all 5 of them. So first one is negative 2. So we look for negative 2 on the x-axis, and then we're going to go up 9. Notice that our graph only goes up to 6. So this point's going to be way up here somewhere. I am not going to graph it since it's off the chart. I've got plenty of other points to work with. So let's go on to the second point, which is negative 1. So I look for negative 1 on my graph. Here's negative 1 on the x-axis. Second number is 7. Again, it's off the chart. This one's fairly close, so I'm going to go ahead and graph it off the grid. We're allowed to do that. So, there, I found my mistake. I just noticed it. So as you can see, that's the good reason why we should have 3 points. I just found my mistake, which is I forgot to put the negative on the 4 right here, this negative. So that's a good way to catch your mistakes. So let's go ahead and remove those points that I put. Let's go ahead and put back that negative 4 here. So let's go ahead and graph it. It should have been down here, the 2, negative 1, and that's not it. Yeah, that's it, actually, and 4, 2. So once you graph your 3 points, this time they do line up, which is what they're supposed to do. And go ahead and connect it. Remember, when you connect it, you go all the way across. And we're pretty much done with this next example. Let's move on to the last example. And my PowerPoint is gone. There it goes. And example number 4, where are you? There it is. So this last example is not in the form that the previous ones were in. This one is in the other form, ax plus by equal to c. Works the same way. Let's start off with our first number, which will be, start with 0, generally our best bet. So we're going to go 3 times 0 plus 2y equals to 6. Remember, the 0 will eliminate this right here. We're going to continue from there. We're going to left with 2y equal to 6. We divide both sides by 2, and we're left with y equal to 3. So that's my first point. Let's go ahead and move on to a second point. So this time, I know that I divided by this 2 right here earlier, so I want to make sure I keep my numbers even. So one more time. Since I divided by 2 here, because of this 2 here on the equation, I have to make sure that when I plug my number in, this 3x is going to be even. So when it combines, so yeah, it's got to be even. So I got to make sure that I plug numbers that are going to keep that even. So if I plug in a 1, it's going to be 3 times 1, which is not even. So I'm going to go with the number 2 instead. So I'm going to go 3 times 2 plus 2y equal to 6. So we're going to have 6 plus 2y equal to 6. Now I'm going to solve this equation. I'm going to subtract 6 on both sides. So 2y is equal to 0. If I divide both sides by 2, I'm going to get y equal to 0. That's my point number 2. Let's get our third point to check our work. I can choose 4 or I can choose -2. So I'll probably just choose 4. Keep them positive. So let's go ahead and do that. So 3 times 4 plus 2y equal to 6. That's going to be a 12 plus 2y equal to 6. I'm going to solve this two-step equation by subtracting 12 on both sides. I'm going to be left with 2y equal to -6. If I divide both sides by 2, I'm going to write it here on the side because I'm out of room. I'm going to get a -3. So let's make sure to go ahead and graph them. Let's make sure I didn't make any mistakes like last time. So let's go ahead and graph these now. So first point is 0, 3. 0 on the x-axis, 3 up. Second point, 2, 0. 2 on the x-axis and stay there. Point number 3 is 4 on the x-axis and down 3. So these are lined up perfectly. So let's just go ahead and connect the line from end to end. Put arrows on it and we are done.